In this video, I will show you how to use graphing calculator to figure out the volume by rotating across the y-axis. There are two methods to figure out the volume by rotating across the y-axis. One is called the disk method. The other is a shell method. Let's talk about disk method. Think about this curve rotated across the y-axis so that you can get this solid. For this solid, you can put millions of different kind of disk like this into this solid. How to figure out the volume? First of all, you need to figure out the volume of one disk. Suppose there's a disk like this. The radius will be the x. So R equals x. Consider this one disk is a cylinder. So the volume of this disk will be pi r squared times the height. The height, think about this is a dy because it's very, very thin. That's why I write down dy, very thin. So for the volume of one disk, it will be pi r squared dy. It will be integral from A to B. And then equals. We substitute the x for this r, you will get the integral from A to B. Pi x squared dy. Let's go to the first example. Find the volume of the solid formed when the following are revolved through 2 pi about y-axis. For A, y equals x squared plus 1 for y is between 2 and 10. You could see the graph like this. This shaded area will rotate across the y-axis. You will get this kind of solid. For this solid, we can use disk method to figure out the volume. This is the volume of revolution by disk method. Pi times from A to B x squared dy. Remember, for this interval, A to B is a y interval. You have to solve for x first. From 2 to 10, x squared, here's a pi to the front, then dy. Then you need to figure out this x squared. So since we have y equals x squared plus 1, x squared equals y minus 1. Therefore, you will write down pi integral from 2 to 10, y minus 1 dy. Then we will put this into the graphing calculator. When you put this into graphing calculator, you need to change every single y into x. Since this y minus 1 is a very simple function, so I directly go to this main screen. I will do second power, that's pi, times, go to math, 9. from 2 to 10. Then you put x minus 1. Then here dx. Then enter. This will be the volume by rotating across the y-axis. Let's go to second example. For y equals natural log of x, the y is between 0 to 5. We know this function will rotating across the y-axis. This graph is y equals natural log of x. The y value will be from 1 to 5. When we rotate across the y-axis, you will see some solid like this. Still, we can put a disk to fill in this solid. We can use this formula to work out the volume of this solid. The volume equals pi integral from 1 to 5, here's x squared dy. And for this x squared, you have to figure out the x first. So we have y equals natural log of x. We can do e to the y's power equals x. So you can get the x equals e to the y's power. Therefore, I got the pi 1 to 5 integral of e to the y squared, then dy. Then we will put this function into calculator. Remember, for this y, you need to change into x. This time, e to the y's power, let's put into y equals. We will do second divide, then x power, then quit. We will do second power, that's pi times math, 9, from 1 to 5. Here, you will put alpha trace y1, then square. Put this is x. Just change every single y into x when you put into graphing calculator. Then put the enter. You will get this answer. This is the volume for the rotating across the y-axis.